Good day, everybody watching. Thank you all for tuning in to this live webinar together with High Mobility. I will be hosting this webinar for you today. We have with us Kevin Valdek from High Mobility, Terry Shane from Biotasphere, and I'm your host, Dave from the IOTA Foundation. We also have Dom in here, so I'll give Dom the word for a bit so he can tell a bit about what this is about. Go ahead, Dom.
Sorry about my voice. So I recently got sick, so I'm sadly not able to partake in this webinar in full. But nonetheless, I'm very excited about us hosting this very first webinar together with High Mobility and together with Terry from Biotasphere. So as all of you have seen, 2018 was really a year where we as an ecosystem, we as a platform for solutions, we're trying to professionalize ourselves, right? And that really meant that we have a very strong developer focus. So this means that we have increased tools, increased our tooling, increased our documentation, and increased our libraries. And the next stage is really that we actually have platforms where developers can easily build applications with and try out these applications in a rapid environment. And this is why I'm very excited today that Kevin from High Mobility will be joining us. So he's like this High Mobility is like this new part of our ecosystem. And I'm also very excited about Terry, like a veteran of our ecosystem, displaying some of the first applications that he's built on top of the High Mobility platform. What's also very exciting is what we will be doing next year together with High Mobility to really push towards this increased developer adoption in the ecosystem. So I'm really looking forward to see what all of you will come up with, and I can assure you that the IOTA Foundation will do its best to really further increase the awareness and also the entire ecosystem for developers. So webinars are a key part of that, but the other part is really that you as an ecosystem and you as a community are also building and showing and also helping each other out to figure out what works and what doesn't, right? Because 2019 will be the year where we want to be ready for the market. And I think this partnership with High Mobility is one way to really pave the way forward for us. So Kevin, maybe you want to introduce yourself.
Sure, thanks, Dom. So we're happy to be here too. So my name is Kevin. I'm the CTO and founder of High Mobility. We are based here in Berlin. That's where I'm calling in. We're building a API platform for developers who want to work with connected car data. And just as IOTA, we have a very strong developer focus. So we provide SDKs for most platforms. We have an API and we have a simulation environment. And now we have this collaboration also with IOTA that you can see how you can combine data coming from the car with the Tangle. And that's one key thing we'll dive into today. I will keep it at that because as soon as we have had the first introductions, we'll also have a dive and screen share into the platform itself.
Cool. Thanks for your introduction, Kevin. Terry, you want to tell a little bit about yourself?
Sure. Welcome, everybody. I hope you can hear me. It says my network connection is poor, but can somebody just confirm that
it's fine.
I am coming through okay? Yeah, good. So I'm Terry Shane, founder of the Biotasphere here in Toronto, and looking forward to showing you guys some of what we've done, taking our proof of concept one step further, and proving once again that the future is with IOTA, with mobility, and with the Tangle. So look forward to sharing with you.
Okay, great. I will take it over for the hosting with the Dom not feeling so great today. So I'll continue from here. Let's talk a bit about the challenges of creating connected car applications. So maybe you can talk a little bit about this, Kevin?
Yeah, so what challenges in creating apps that work with car data? I mean, it has been, the car industry itself is still today mostly a closed environment if you're a developer or have ideas and want to work with that data. But at the same time, as we've seen in other industries, especially in smartphones, smart homes, products have become open. We have open APIs, possible to build on them. In the car industry, it hasn't really happened yet. But there are different APIs, so it is possible, but it's pretty protected. So that's one of the main challenges you see, that even if you have a great idea to work with car data or even build some kind of service for mobility, it's not that easy to approach. And that's the second thing, is that even if you have built something using some kind of APIs, how can you get it mainstream? How can you get it onto the market? And that's another kind of thing, a big challenge that we have seen, and that brought high mobility to life, to kind of create a transparent environment, how to build those type of things. And that's one aspect of it. And Dave, you can speak about how you see it and what's the challenges.
Yeah. So there are some other challenges as well, of course. In terms of data protection, you have to send the data securely from the car to some other location or distribute it over the world. You want to make sure that no one can intercept this, but also that this is always available. Cars don't have the best internet connections available all the time, so there's a bit of a challenge there as well. And there's, of course... Yeah, sure.
Sorry, I forgot. I can drop in quickly, as you mentioned, that the availability, that's maybe the key thing, even that if you're building something, typically have a product available so you can test it. I mean, if you're building an iPhone app, you can run it on a simulator, but with cars, it's much more difficult. I mean, if you're building something for a car, you have to test it, but then you have to have a physical car next to you.
Yeah.
And if you're working with different car models, how can you try a wide range of different cars? So if you just work with physical product, that's one big difficulty.
Yeah, definitely.
Some type of simulation environment like in other platforms.
Yeah, these cars are not cheap to test with, and if you need like 150 of them to support a big user group, it will be a very hard sell for any investors in your company, I guess.
Yeah, you have to get a car farm.
Yeah, would be a nice way to get your employees to work if they don't work from home, of course. But yeah, and
actually. Sorry, if I can just jump in.
Yeah, sure.
My big thing here is, it's great from a technical perspective, but we're all about getting stuff to market, and sometimes the big problem is, how do you iterate, how do you develop, and how do you get stuff in front of people so that they can see this is real and do it quickly? And that's really what we're excited about here today.
Yeah, definitely. So that's one of the challenges. Another challenge is if you want to have your car talk to chargers, there will always be user interaction. How can we automate that stuff to make sure that you don't have to insert a smart card to pay for your charging, etc. Those are all things we can solve, and I think we can do that with the High Mobility API in combination with IOTA. The IOTA workspace is now available within the High Mobility platform. Maybe you can talk a bit more about this, Kevin?
Yeah, so we have a concept called workspaces in our platform. So you go in our platform, we have all documentation, it's all standardized, and it's all based on a standardized car API. So the goal is that as a developer, you can work with one integration, with one API, and then it will work with all different car makers that are connected in our platform. And to kind of get this simulation environment or get the ideas going, we have something called workspaces. So today we have Porsche workspace. We have another workspace, or a few other workspaces coming up from other car companies in the near months. And then we have also workspaces we use for tools that we promote that developers can use in combination with car data. And that's where we have the IOTA workspace. So inside of the IOTA workspace, we have different blueprints, how we can use the Tangle together with car data. And then you have these different workspaces from car makers, for instance, Porsche, where you can actually test it on virtual cars, for instance, Cayenne, or some concept cars that Porsche has, and you can test that and in the end also submit it.
Yeah, great. There are currently 2 blueprints available for IOTA in there. One is pretty cool. You can actually have a virtual charging station connected to a virtual car and make the car pay for a charge. And there's another example where location data of a car is logged through master authenticated messaging to the IOTA Tangle. If you want to check them out, just create an account on the High Mobility website and you can have a look at the blueprints. Okay, let's switch over here. let's have a look at what we can do with high mobility. Let's share your screen and see how it's going to work.
Yeah. Let me go ahead and share my screen. Okay. So Dave, you can see it?
I can't see it yet.
Yeah. Give it a moment.
There it is. Yeah, great.
Okay, perfect. So here I'm on highmobility.com. So if you would go in there right now or later, you can already register and get in. But even though the documentation I will start with is publicly available, so that's one part of the kind of transparency that we want to create in this, that most things, as in other industries, it's openly available. The IOTA API is how we call our standardized car API. There we have standardized all different types of data that you could get from the car, like diagnostics data and the vehicle location. It's all defined in the IOTA API. So even if you work with different car brands, you would always work with this one protocol. We do offer SDKs for Android, iOS, Node.js, and the REST API for all the other platforms. But to begin with, we can have a look at what type of data that is available. And you can see we have fairly a large amount of different categories that we have done. We have diagnostics data, digital key, chassis information, parking APIs. So in total, we have almost 300 different data points that we have by today defined in this protocol. And if you would jump into something like diagnostics, we can see how it's built up. So this is really getting very techy at the moment, but the IOTA API in its core, it's a binary protocol, but that's why we have these SDKs and REST API that abstracts the working with it. So I can open up here instead the REST API, we can see more human readable information. If I would expand on diagnostics, you can see we get mileage, engine oil temperature, speed, and other type of data. So if you're kind of interested in or have an idea, the most straightforward way is to really scroll through the different type of capabilities, as we call it, exist, and have a look at what type of data you can get from it. Once you know, you can download the different SDKs. They're mostly available on different NPM, is the Node.js SDK, iOS, you can just download, and then you can start testing with in the workspaces. So the interactive part are the workspaces, and that's perhaps the most interesting part to talk about. So if you open the Porsche workspace, you can see some information about Porsche, about the latest used emulators. And I have a bunch of different emulators that I've been working on. So the emulator section is as in the beginning, I kind of hinted at, is a simulation environment, because you want to be able to test your application, and the emulators, they're really like a digital representation of a car. So instead of having a real car, I could just launch the emulator here, and I would see the Mission E. This is a concept car presented by Porsche, and I can see these different data points. For instance, it's not charging at the moment, it's locked, and this is representing like a physical car. In the bottom, I have a log, so I can see it's just initialized, not much going on. And to the right, I have different types of APIs that are available for this simulator. So here we can see the same type of things we saw in the documentation, but now more in an interactive mode. For instance, the speed of the car, and I can change the speed of the car. So if I'm testing an application that somehow reacts based on the speed of the car, I can test it here. I can set this to 19 or 20, and the next time I use the API to get the data, I would get this new state. So it's completely possible to test different scenarios. Another part is simulations, and this is a place where we can have real data. And here it's possible to define some different types of scenarios. You can see that the vehicle is here, and 5 seconds later we have a horizontal time span here. The vehicle moves around, and I can change all types of states of the car. And when I run it, just can close this, I can play it directly here. It opens a small map, and in the log I can see that every 5 seconds the vehicle location updates, the speed updates, and here we have a homemade, but you can create your own simulations, and we will keep adding more real trips scenarios. So we will have trips, for instance, for a car driving around in Berlin, and other type of things that we will enable. So you don't have to combine your own scenarios. You can really just pick from the shelf different kind of driving behaviors and that's how you can test your application. One last part I could show is if I close the simulation, is something more interactive. So I have the car or emulator open here. We have a bunch of different sample applications that are available on GitHub. So if you go to GitHub and High Mobility, you can see we have different sample applications for Android, iOS, and one of them is for Node. And I have taken this sample application, downloaded, because HM Node Auto API Explorer. So if you would check that out, it's available with Apache 2.0 license, and there's instructions how to get started. I have already started it in my computer, and I can open a new window to load it. So here it is, but let me do a split screen. Then we'll do a more of a small interactive demo. Let's try again. Okay, so here on the right side, I have this sample application. It's running in my local host, and to the left, I have the car. So let's start to look at the state of the vehicle. So if I open the door lock state, I can see that all the doors are locked on this car. But before I can start to interact with it, I have to kind of authenticate my local application to access this. So I press login, and now it's redirected. So we are actually going through an OAuth consent flow. In the development cycle, it's just simulated, but in the real life, it would work the same, that the car owner have to actually give the consent that your application can get access to the data. Here I can go ahead, select the vehicle. So these are all the different vehicles that I have in my own account. I choose my test vehicle because that's the one that I have open here. Just says that it's requesting permission to do the following: full control of the car. Yes, it's okay for testing. And now in this sample app, we just get the diagnostic state, the door lock state, and display it here. And in this application, I show that the doors are all locked, which I see it's correct. And I have a button to unlock it, so I will press. And now we see that it all states in the emulator changed to unlocked. I can also see in the log that we had the sample app incoming command, telematics command, for locking or unlocking the car. And the same thing is if I want to change other things, that, for instance, the mileage of the car, here I have 50,000 kilometers. I can go back. I can see the same number here. Let's simulate that the car has been driving around a lot. I refresh the data, and I get the new data here. So pretty straightforward way of kind of working with it here. We just display the information, but I'm pretty sure that, well, I know that in the next example by Terry, we will actually see that how he used the SDKs and APIs to get the data, and how much more things you could actually do with it. But before that, we will, just as a last thing, have a look at the IOTA workspace. So in the same as in the Porsche workspace, we have a bunch of information here, but the key part are the blueprints. So currently there are 2 blueprints that have been added by IOTA to their workspace, of ideas of how you can combine car data with the Tangle. And I would let Dave, you speak a bit about what the first blueprints are about.
Yeah, thank you very much. Nice demonstration. It's the first blueprints. Oh, let me keep the screen up. We have 2 blueprints, like I already mentioned. One is the charging payment blueprint. This basically lets you connect a virtual car to a virtual charger. Once they connect, the charger will request a payment. The car will automatically transfer 1 IOTA to the charger, and as soon as that's done, the charger will start charging, and this will all be completely fully automated, so there's no user interaction involved. As long as your car's wallet has some funds in it, it can actually be used. That's the first example, and the second example is the most authenticated messaging example. This is the one I created myself, so I know exactly what it does. It's a example where the location of the car is being requested every 30 seconds, and it is sent over the Tangle through masked authenticated messaging in a secure encrypted stream back, only if the car location changes. So if your car is standing still, it won't be spamming the Tangle with location updates all the time. This also gives you a certain kind of audit trail. So if you ever have to prove that you were at a certain point with your car, you can always say, oh, here's the transaction in the IOTA Tangle, or here is the reference to the transaction. I was actually here, and that can be useful for multiple use cases. So yeah, that's basically the examples for high mobility right now, the blueprints. Maybe some more will follow. I can encourage you all, if you're a developer, have a look at the high mobility blueprints. They are pretty damn good. And the API is very easy to work with, as well as the IOTA libraries, of course. So feel free to work with it. Thanks for this demonstration, Kevin.
Yeah, happy to.
No worries. We will be having a look at what Terry has for us. Terry already showed a very cool presentation about his insurance platform a while ago. You might have seen that before. And we will now have a look at his presentation, how he's using high mobility together with that. So go ahead, Terry.
Excellent. Thank you so much, guys. So today, obviously, we're going to show you some of what we've done with the Insure My Car project, taking it a little further than it was before. For those of you who haven't seen it, we will just give a little bit of background. So a few months ago, we did a deployment and broadcast live from a Tesla in Toronto, where we hooked up the IOTA Tangle to some logic inside the car and started this project called Insure My Car, which essentially gives the vehicle the power to insure itself. And we imagined a world in which the vehicle, everybody's car, would be an autonomous economic agent. And today, everybody, for the most part, hates buying car insurance. They do it once a year. And almost certainly after you've bought the insurance, you feel like you've missed the best deal or you didn't have the time to shop around. So what would happen, we imagined, in a world in which the car actually did the thinking for you, if it could buy the insurance on its own behalf and could do it not just once a year, but once a minute, once an hour, once a second, based on the risk that it actually provided to the insurance company. So not only did we imagine the car making those decisions, but being able to choose between a variety of competing offers. And those competing offers might come from a single insurer with different offers, or they might come from multiple insurers. So for our purposes, we had 3 different offers. They could all come from one insurer. They could be an entire marketplace of insurance. And we assumed that there was no knowledge about who was driving the car, because as we move from a period in which we have sole ownership to a period in which more and more safety features and autonomy are introduced until we achieve full autonomy, it isn't always the owner of the car that's going to be driving, and we wanted the car to be able to make those choices in real time. So for the proof of concept, we had 3 imaginary insurance offers. Standby insurance offers really, really low rates for the 93% of the time that many cars are parked in the driveway at home overnight or at the office parking lot, really not traveling and therefore providing very little risk. So standby insurance is very inexpensive when you're not using the car, very expensive when you come out of park. At the point that you come out of park, other offers will be cheaper and the car will auto-select them. Tortoise Insurance has the best rates as long as you're not speeding, although the faster you go, there may be special conditions that increase your rates. But if you do exceed the speed limit, then the BF Rocket insurance will kick in, and everybody is willing to pay more for gas if they want to put their foot down because they're late or they want to show off. Why wouldn't they pay more for insurance, especially if they represent a higher risk? So we streamed live from the car. We built the interface. The car was able to talk directly to the IOTA tangle, monitor the status of the car via the API. And so here, when the car went from park into drive, we switched from standby insurance to tortoise insurance. Our cost per minute rose. And then as the car started to drive faster, the rates went up a little. And then when we were really speeding, we kicked into this BF Rocket insurance. And the car was purchasing insurance minute by minute, mile by mile, kilometer by kilometer, in real time, with no personally identifying information coming from the user. Now, this was all fantastic and absolutely spectacular until we ran into the problem that we didn't always have access to the car, and the developers often wanted to make changes. Now, we also wanted to be able to make other influences on the rate of insurance, such as which safety features were in place, what the weather was like, what other traffic conditions were like nearby where the car was driving. The problem with the physical car is that I either had to flip the keys to the Tesla to the development team, which probably wasn't the wisest of ideas, although they did encourage me to do that. But every time we needed to make a change in the code or a change in the logic, somebody needed to get in the car and drive it. And the car had to be here, and it had to be available, and it had to be in the vicinity. So one of the amazing things that the high mobility solution makes possible is for us to actually interface with a virtual car. So we can actually talk to a virtual Porsche. We can integrate our technology with the virtual Porsche, try all kinds of scenarios that you wouldn't be able to do with a real car on real roads, and actually try out all kinds of things without needing a physical vehicle all the time. So having built Insure My Car specifically with the idea that we had abstracted all of the API interfaces with the vehicle was actually very straightforward and quite easy for us to then migrate that to work with high mobility. So what I'm going to do now is show you a video of the integration with the high mobility app using a Porsche. In this particular case, we're using a virtual Porsche, and this time, instead of driving it around in Toronto, I thought it would be kind of fun if we parked it outside the Smithsonian and drove it right in front of the White House, where we didn't stop too long because I don't think electric vehicles are that popular there. But we drove past the White House and then across the Potomac River, where our virtual driver puts his virtual or her virtual foot to the floor before parking on the other side. And so I'm going to show you how all of that works in this short clip. So here we go. And you'll see we modified the insurance slightly in this particular case. We got rid of the BF Rocket insurance. And here is our virtual Porsche. It's running standby insurance. And over here in high mobility, we're going to run our simulation in Washington, D.C., where we have it driving from the Smithsonian along Constitution Avenue past the White House. So we're going to just start that simulation over here in high mobility. And just like Kevin did before, we're going to split screen this so that you can see high mobility running on the bottom, Insure My Car running separately at the top. And the car is parked. It's on standby insurance. And in just a few moments, the vehicle will come out of park. And when it comes out of park, standby insurance will no longer be the cheapest option, and the car will automatically select a more efficient option. And as it comes out of standby or into drive, you'll see now tortoise insurance was selected. The cost per minute has risen for this reporting period, and the high mobility vehicle as well as the Insure My Car location are now both updating in real time, showing the new location. Now, as the vehicle goes above 30 kilometers an hour, as it passes the White House, special conditions kick in, and we're paying additional fees. The rates go up, even though the car, if you look at the speed, has now temporarily dropped. And the vehicle will now continue going. It's doing 55 kilometers an hour. Sorry, it's doing 54, 58. And in just a few moments, it is going to get onto the bridge, cross on the highway across the Potomac River. And as it does that, our virtual driver will accelerate hard. And you'll see this in just a moment. And at the point that they start speeding like this, and the speed goes above 100 kilometers an hour, will happen very, very shortly. You will see a new condition kicks in, and we go from tortoise to rocket insurance at ludicrous speed. We fly across the bridge at about 150 odd kilometers an hour before slowing down. And at the end of each reporting period, all of the telemetry data, all of the insurance data is written in an encrypted and secure fashion, recorded on the tangle, and the car carries on with its business. And the driver, whoever they happen to be, doesn't really need to worry about are they getting the best deal, because they're always getting the best deal. The insurance companies get data that today they probably couldn't have access to, and we can add other information that we get from the car and from the driver and from the environment that allow us then to modify the insurance so that everybody is getting the best deal. And we can abstract this not just to personal cars, but to fleet vehicles, to trucks, to all kinds of other scenarios outside and beyond this. So hopefully that gives everybody some sense of what we've been up to. Let's just flip back over here. Happy to answer any questions or discuss other bits and pieces that we have here.
Thank you very much, Terry. Great demonstration and a real good use case of IOTA in combination with high mobility. When I saw your demonstration last time, I really thought it was very well suited as soon as I heard about high mobility. So I'm glad to see you have it integrated now as well. We can do some Q&A in a couple of moments. Let's do one or two more slides before we go to that. Okay, so yeah, this is not just it. There is more stuff to come. You can follow our Twitter and the High Mobility channel on Discord. We have a special channel for that to discuss this. There will be more live coding sessions by me. There will be other blueprints as well, probably. And you are, of course, also very much free to create something yourself as well. We might even send some ledgers to people who actually create something very cool with the High Mobility API and IOTA. So definitely check it out. Please check out highmobility.com as well. They have excellent documentation, and as you might have seen from the demos, the simulators are pretty awesome as well. And there is a cool competition coming up with high mobility, and maybe you can talk a little bit about this, Kevin.
Yeah, I can. First of all, Terry, I don't get tired of seeing the demo. I think it's a great way of showing what you can do on the platform. So really nice. Great job.
Thank you.
Yeah, for what's coming up is we have had different hackathons and online competitions. So one of the something that the simulation environment allows us to do is to have online competitions and not only things taking part in hackathons at physical events. We have one next online competition coming up in February with Porsche, called the Porsche Next Open Innovation Competition. We had one last year with a bunch of different prizes, and in the end, the top 12 teams, they were invited twice to Stuttgart and second time to the award ceremony at the Formula E championship in Berlin. And there they get to present to senior management level people at Porsche, and also the winning teams got to engage with Porsche to do to follow up and do pilots together with them afterwards. So I think that this, if you have built something, definitely do take part of the Porsche Next OI competition in February.
Cool, very cool. I'd love to see some people participate in that. It sounds like an awesome opportunity. So if you guys want to get in contact with any of us, here are some contact details. You can always find us using our email address or a Twitter handle. In my case, I'm a regular on the Discord, as you might know, so you can find me there. I think this is a good time to jump into the Q&A session. So if you have any questions, just drop them in the YouTube chat or Discord or whatever. Mark is constantly monitoring it. And I see we already have a bunch of questions in. So let's jump right in. A question from Hund Katzefish. Does the data of HM cover all requirements of the minimal data set for research projects and e-mobility in Germany by BMSV or BMU? I don't know exactly what that means, but you might have an idea.
I have an idea, but I'm not 100%, so I don't know exactly what the requirements of. I think it's the BMVI. Yeah? So I'm not German myself. I'm from Estonia, but I can understand so much. I don't know, to be honest. I think that's something to check out. If you have more information about it, feel free to send it, and I will have you an answer to you. We have a fairly large data catalog, so I can imagine that we should have some coverage.
Cool. Thank you for that. We have a question from our lovely Mathieu Vjost, the Tangle developer. As anyone can anonymously publish data to any IOTA address for free, how to make sure that the data we read have been sent from the car? Is that something you want to answer, or should I jump onto that?
I guess the question for you or Terry.
Yeah. Okay, so if you publish to the Tangle, how can we make sure that it has been sent from the car? It's a very good question. First of all, you can use master authenticated messaging to send encrypted data with a shared key at this moment. So only the people knowing that key can actually send and receive the data, or you can actually receive the data. So if you don't have the key, you can't get the data from the Tangle, which is some form of protection. We are also working on a new version of master authenticated messaging, which has a private key, public key encryption in there, which should make it a lot more suited for that.
I could actually bring out one example. So this is not something we have in the simulation at the moment, so you will not see it, but we have done different proof of concept. So if you would look into our SDKs, you would see that it's built on public key infrastructure. That means that that actually the data you get as an application, it has been signed and encrypted with a private key.
Yeah.
It's the basic form of cryptography, but at the same time we have done POCs where we have actually done the signature in the car, so you would be able to do it. And then, of course, if you combine it with the Tangle, then you would have some kind of footprint, but that's just brainstorming at the moment.
Yeah, exactly. It's always something you can implement yourself as well. If you're working on a custom thing on top of the Tangle, it's free protocol. You can implement something yourself, but it's also something we're working towards with the new MEM, I believe. So we might see some of that in the near future. Dom soon. We have a question for Terry here, I guess, from Crazy Thump. How will switching between different insurance plans on such a short time frames ever work with the Tangle? It takes several minutes to push the data to the Tangle.
So the offers don't have to be, so the switching can be done by the car based on offers that it has received and is essentially caching. Whether it is entitled to switch to those based on the parameters and the telematics that the car is producing is something that, again, will be decided by the vehicle. And that's why you want an immutable record of what happened, because you can't always be sure that the car will always have connectivity. So the system is not predicated on the car being able to go out to the Tangle or out to the cloud to find which is the current insurance offer that might make sense. It will have a marketplace which it can select from, but it will only be entitled to choose one of those offers if it meets the criteria that offer has. Also, just to pick up on the previous question, it's important to understand that at this point, we're still dealing with virtual cars, and these are still proofs of concept. As we move beyond proof of concept to minimum viable product to full-blown production, we will obviously be dealing with issues of confidentiality, of encryption, security, and these are the things that will get worked out as part of that process. Today, we're just trying to get people to think in new ways, to see new possibilities, and that's really, I think, what we're all out to do for today.
Amazing. I think that answers the question. The same user has another question about this. What happens if I get into an accident, but the last change in insurance hasn't been registered to the tangle yet?
Again, in what circumstance does the accident happen? Is it a fender bender? Is it, sort of like a Princess Di pile up inside a tunnel with no communication with the outside world? The car is actually collecting and storing the data. It is not writing it, 100 times a second to the tangle. We collect the telemetry, the car is making its decision, and at various intervals it writes the data to the tangle. It also may write data to other places, but ultimately the car is acting as its own black box storage. And these are the edge cases that I guess need to be worked out in the insurance space with car manufacturers, with governments, with insurers, and all interested parties. Excellent question, and would love to and are already starting to engage with organizations in the space to discuss these very issues.
Cool. We got another question from Marcel Sieg. What's the benefit for the insurance company? What's the benefit?
Excellent question. I guess I'd probably turn the question around. What's the risk to the insurance company if they don't examine this? I think every taxi driver and every taxi company in the world said that Uber would never be a risk. What was the risk of taking that for granted? Everybody hates buying insurance. Everybody thinks they're being ripped off for insurance. Insurance companies are limited often by governments in terms of the premiums that they can charge, not to make as much money as we all think they do, but they're forced to spread risk over very large populations because the actuarial models that car insurance is based on today are really laggy, based on data that's 6 months out of date and using models that are 100 years old. So in this situation where the car represents no risk, the insurance company can still make money but has almost zero exposure. Today, there's a lot of competition for airfares. The airfare or the airlines can't really make money on the airline ticket anymore. They make their money on, well, would you like extra legroom? Would you like priority boarding? Would you like a meal with that? If you want to drive fast, that's great. You'll pay a premium for that, but the premium reflects the risk, and the margins for the insurance companies with some of the other things that they get to benefit out of from this should actually be larger than just selling insurance in a competitive environment. And the data that users will be willing to share and that insurance companies get to collect as a result of this means that everybody wins. Because today, nobody trusts anybody. The car companies want to keep the data for themselves. The insurance companies don't want to share with other insurance companies. And as a result, everybody loses.
Right. Thank you very much. I think that answers the question very well. I have some other questions as well that have been sent in before the screencast. Let's do one for Kevin. Let me see. Does the High Mobility API incorporate IOTA capabilities, or are those still developed by each app outside of the High Mobility environment?
Yeah, in this case, it's developed outside of the environment. So more or less the blueprints, they show the combination. On one side, they consume the API from High Mobility, and on the other side, it works with SDKs directly from IOTA. So I guess that could be something to possible exploration in the future, how it could even be done in potentially a deeper integration.
Okay. And is every vehicle in the HM platform a full representation of the functionality of a real car? Is it an actual accurate digital clone?
No. So this provides an impetus because we as the car industry is not, as more or less as Terry said, it's not fully there yet. So with the workspaces and the car and the virtual cars, we bring out all different capabilities, and so you can work with it. On the other hand, we are already live with live data in our platform too, which we will have more public exposure about that in a few months. But basically, there are hundreds of thousands of cars that you can actually access, although the data set are more limited than what you can see in the current emulators. But we will post more information about that. But once you do work with it, it's not a big difference for you as a developer, because the API is the same. You can expect the same behavior. Of course, sometimes some things takes longer time in some cars, the more latency with other cars, and that's why we have different types of emulators. That in the end, we have on a street a car that has slow connectivity just because of the hardware, and we have something like much more faster, and something like a Tesla, which uses more advanced hardware than some cars. Then that would be reflected. So we are planning in building in some kind of filters, so you can really test with different emulators and be more or less sure that, okay, this is how long things would take, and this is how it would behave in the real world.
Okay, cool.
If I can just
sure.
if I can just add something in there, Dave. We built our application with the API infrastructure abstracted so that we would be able to do exactly this. But as soon as we'd done the live demonstration with the Tesla, we were contacted by a car manufacturer who said, we're really interested in showing this to senior management, but there's no way we're taking this to them and showing them what you've done with the Tesla. How do we get our car in your application? Well, could you send me a car? Well, no. So that was a huge problem. It took about 2 to 3 days to complete the integration with high mobility so that we could simulate the Porsche. And now we can do things like simulate a situation where, you know, how would your insurance change if you were driving at 100 kilometers an hour and you had a flat tire? Or, you know, how should your insurance risk alter if there are 4 people in the vehicle and 3 of them aren't wearing seatbelts? So there's some very interesting things that you can solve for in this situation, which you can then go to a manufacturer and say, here's the solution. Now let's start moving it to proof of or minimum viable product with a real vehicle. And now you have something to have a conversation about, whereas previously it was just conceptual.
Okay, great. Thanks for that addition.
Yeah, exactly. I mean, if you move from the same thing, if you move from the simulation environment to a real environment, even the live APIs that we have today, there's no code changes except that you get a different set of API keys and certificates. So a configuration question, not so much about doing any other type of API integration.
Yeah, cool. I had a question about it actually. If I want to move over to a real production vehicle, what would be the steps I would have to take in order to get my vehicle connected to high mobility?
Well, there is an approval process. So we are rolling out something called verified services, and this will be launched end of January, latest beginning of February, where in the platform you can already submit your application with a link and some descriptions. We have to make sure that compliant to data regulation. But basically, then when you get verified from us, you would get in the platform you would have the production, so to speak, API keys available, and based on them you can connect to real cars. Then if you would have that car available, you would, as a car owner or with a physical car, have to then consent to your application to get that data. But that type of consent flow is the same as we see in any type of web applications today using OAuth. So nothing strange. But so that's how it will be rolled out. Currently, if you want access to real data, we have something called pilots in our platform. You can submit it. And a pilot is more of a manual process that we look at it and we know we are speaking to these car makers that have a workspace, also other car companies, mostly in Europe today, but increasingly also in other parts. And there we do introduce that, look at this pilot that was submitted. They want access to real car data. These are the data points they're using for these type of services. And then you could get something going also. So we try these different posts. So we will have one automated approach for some data set, and if you want more data, you can always submit it to be considered.
Okay, cool. Thank you very much. I have one more question for Terry. And you already kind of answered it, but I think it's a cool thing to bring up again. How long did it take you to migrate your awesome proof of concept to the high mobility platform? Was it a hard process or?
It was remarkably easy. Deceptively simple, but primarily because we'd done the hard work in advance to make sure that when we built the original platform, it was built with a vision of being able to migrate it. And then once we got access to high mobility, it was actually very straightforward. Kevin and his team were absolutely fantastic in facilitating that. And it allows us to go so much further. So for example, we're also working with palm vein scanners for human identity. So we can combine information about the car with opt-in information that doesn't reveal necessarily who the vehicle driver is, but asserts that the person at the wheel of the car, as we go from fully manual to fully autonomous and all the grays in between, we can in fact ensure that the person behind the wheel provides the biometrics to guarantee that they are licensed to drive in the jurisdiction in which the vehicle is currently located. And so there are all kinds of possibilities that can be added as you combine not only the vehicle with the driver, with its environment, and in a world in which vehicles will be moving not just people, but packages. These are the kinds of solutions that we're going to need to build a new world, and very excited to be part of it.
Yeah, it sounds really great concept, and it can only benefit everyone if you think about it like this with the verified identities. And yeah, awesome. Okay, I think that are all the questions I have at this point. Oh, nice background. If you want to get in touch again with us, here are our contact details. Always free to send us an email or whatever. I want to thank you, Terry and Kevin, both for joining us here in the webinar. Very useful information, and I really hope that everyone who wants to develop something on top of high mobility or with IOTA will join us. Of course, there are a lot of great concepts to think of. You just need a little bit of imagination to get there. So I think I will wrap it up. Thanks again, Terry. Thanks again, Kevin.
Yeah, thank you. Thank you both. Thanks all for watching.
And thank you all for watching. And I guess I'll talk to you guys.
Happy holidays.
Happy holidays, of course. Very much. Okay. Have a good day, everyone. Bye-bye.
did